Hello student, myself Anil Dobriyal. Student, today we will do exercise 1.1. And what is the question number 1 of this exercise? Determine whether each of the following relations are reflexive, symmetric and transitive. That's what we are taking. Relation R in the set A 1, 2, 3 up to 13, 14 defined as relation R is equal to xy such that 3x minus y is equal to 0. So we will put values of element from set A to this relation. Like when we are putting 1, so 3 is coming because it can be changed, like y is equal to 3x. So 1, 3. When we are putting 2, so 6 is coming. When putting 3, then 9 is coming. When we are putting 4, 12 is coming. And greater than 4 value we can't put it, because when we are putting 5, so 15 is coming, and 15 is not in set A. So domain and range both should be in set A. So now we observe that 1 belongs to A, but 1 1 not belongs to relation R. 1 1 is not here in R. So reflexive relations definition, we study that if AA belongs to R, then it will be a symmetric. AA means 1 1, 2 2, 3 3 belongs to R, then it will be a reflexive. But this time it is not coming like this. So R is not reflexive relation. Now 1 3 belongs to R, 1 3 is here, but 3 1 is not belongs to relation R. So in symmetric relation definition, we studies that if AB belongs to R and BA is also belongs to R, then it will be a symmetric relation. But here this is not coming, so R is not a symmetric relation also. Now 1 3 belongs, now also 1 3 belongs to R and 3 9 belongs to R, but 1 9 is not coming here, so it is not a transitive relation also. So R is neither reflexive, not symmetric, not transitive. So this is our required answer. Now we are doing question number 1, second part. Relation R in the set N of natural number defined as R is equal to xy such that y is equal to x plus 5 and x less than 4. It means we have to put values of x till 3. 1 2 3 will be the value of x. So we'll put values here, y will come. So when we are putting 1, so 6 is coming, 2 7 is coming, 3 8 is coming. So relation is 1 6 2 7 3 8. Now A is 1 2 3 because we put values of A here. Now we are observing that 1 belongs to A, but 1 1 not belongs to R. 1 1 is not here in this relation, so it is not a reflexive relation. Now 1 6 belongs to R, but 6 1 is not belongs to R. 6 1 is not here, so R is not a symmetric relation also. Now for AB belongs to R and BC belongs to R, we does not have AC belongs to R here. This case is not arising here, so it is not a transitive relation. Thus R is neither reflexive nor symmetric and not transitive. So this is our required answer. Now are taking its question number 2. What is the question number 2? So that relation R in the set R of real numbers defined as R is equal to AB such that A less equal to B square is neither reflexive nor symmetric and not transitive. So given relation we have here. Now we are doing it hit and trial method. So now 1 upon 2 belongs to R, but 1 upon 2 is not less than equal to 1 upon 2 whole square. So this condition is not satisfying. It means 1 upon 2 belongs to R. So R is not reflexive relation. It should be not belongs to. Yeah. So R is not a reflexive relation. Let 2 7 belongs to R, but 7 2 not belongs to R, because this condition will not satisfy with this number, because 7 is not less than or equal to 2 square. So R is not symmetric relation also. Again 1 upon 2 comma minus 4 belongs to R because 1 upon 2 less equal to minus 4 whole square, and minus 4 comma 1 upon 2 belongs to R because minus 4 less equal to 1 upon 2 whole square. But 1 upon 2 not belongs to R. We just prove here. So R is not transitive relation. Therefore R is neither reflexive nor symmetric nor transitive. So it is very good question. Question number 3 we have, check whether the relation R defined in the set 1 2 3 4 5 6 as R is equal to AB such that B is equal to A plus 1 is reflexive, symmetric or transitive. So we have to check. Now as we have given and relation we have given, we will put values of A here. 1 when we are putting 1, 2 is coming. When we are putting 2, 3 is coming. 3, 4 is coming. 4, 5 is coming. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 6 will be the required relation. Now 1, 2, 3, 4, 5, 6 belongs to A, but 1, 1, 2, 2, 3, 3 this type of relation is not belongs to R. None of the relation is here. 1, 1, 2, 2. We are not observing it here. So it is not a reflexive relation. But now we are doing 1 upon 2 belongs to R, but 2, 1 is not belongs to R. 2, 1 is not here. And the type of the relation is not here also. So R is not symmetric relation. So 3, 4 belongs to R and 4, 5 belongs to R, but 3, 5 not belongs to R. 3, 4 and 4, 5 is here, but 3, 5 is not here. So it is non-transitive relation also. Thus R is neither symmetric, neither reflexive nor symmetric and nor transitive. This is our required answer. Student, question number 4 we are doing. So that the relation R in R defined as R is equal to AB such that A less equal to B is reflexive and transitive but not symmetric. Here we have R is equal to AB such that A less equal to B. Let B is equal to A, then AB belongs to R because A less equal to B. So R is reflexive relation. Now since 1 less equal to 2 but 2 is not less than or equal to 1, so 1 2 belongs to R but 2 1 is not belongs to R. So R is not symmetric relation. Now let AB belongs to R implies that A less equal to B implies that BA not belongs to R. If A is belongs to R, so BA will not belongs to R. Both A less equal to B and B less equal to A can't hold true together. Either this will true or this will true. So both can't hold true together. So R is not symmetric relation. Let AB belongs to R and BC belongs to R implies that AB less equal to B and B less equal to C implies that A less equal to C and AC belongs to R. So this relation is arising. So R is transitive relation. So the given conditions we proved here. Now question number 5 we have, check whether the relation R in R defined by R is equal to AB such that A less equal to B cube is reflexive, symmetric or transitive. So we have here given relation AB such that A less equal to B cube. Let A is equal to 1 upon 2, then 1 upon 2 not belongs to R because cube of 1 upon 2 will be 1 upon 8. So this relation is not satisfying given condition because 1 upon 2 is not less than equal to 1 upon 3 whole cube. So R is not reflexive relation. Now let 1 upon 2 belongs to R but 2 1 not belongs to R because 2 is not less than or equal to 1 cube. So R is not symmetric relation also. Now 9 3 belongs to R and 3 2 belongs to R, but 9 2 does not belongs to R because 9 is not less than or equal to 2 to the power 3. So R is not transitive relation. You can do this question by writing method. You have to only give definition in that method. You have to learn definition of reflexive, symmetric and transitive. You have to write definitions and then you have to write that. Hence this question is proved. So this is our required answer. Now question number 6 we have, so that relation R in the set 1 to 3 given by R is equal to 1 to 1 is symmetric but neither reflexive nor transitive. Let A is equal to 1 to 3. So R is 1 to 1. 1 belongs to A but 1 not belongs to R. 1 is not here in this relation. So it is not a reflexive relation, because for reflexive A belongs to R. It should be the it is the condition of reflexive relation. So it is not it here. Now 1 2 belongs to R and 2 1 is also belongs to R. 1 2 is 2 and 2 1 is here. So R is symmetric relation. Now 1 2 belongs to R, 2 1 also belongs to R, but 1 1 not belongs to R. So R is not transitive relation. So it is a very good question. All the three conditions we can understand very easily in this question. Now question number 7, so that the relation R in the set A of all the books in a library of a college given by R is equal to xy, such that x and y have the same number of pages is an equivalence relation. For an equivalence relation should be reflexive, symmetric and transitive. So I will check three of the conditions. If it is coming, then it will be a equivalence relation. Here we have R is equal to xy, such that xy have same number of pages. Now obviously if x and y have same number of pages, so xy belongs to R, because number of pages in first will equal to number of pages in second. So we can say 1 1 belongs to R or xx belongs to R. So clearly R is reflexive relation, because it's satisfying all the conditions of reflexive. Now xy belongs to R and yx implies that yx is also belongs to R, because number of pages in both the books is same. So we can write any of the books pages first, that will be equal. R is a symmetric relation. Now xy belongs to R and yz is also belongs to R, and implies that xz is belongs to R, because the number of pages in books x and y and z is same. So R is transitive relation, hence R is an equivalence relation. This is a very good question. We are taking question number 12. And what is the question number 12? So that the relation R defined in the set A of all triangles as relation is equal to T1 comma T2, such that T1 is similar to T2 is equivalence relation. Consider three right angle triangles T1 with sides 3 4 5, T2 with sides 5 12 13 and T3 with sides 6 8 10. Which triangle among T1 T2 and T3 are related? So it is very simple question. So solution we are doing here. We have T1 T2, such that T1 is similar to T2. T1 is similar to T2. If two things are similar, if T1 is similar to T2, then T2 is also similar to T1. So we know that every triangle is similar to itself. T1 is similar to T1 also. So we can write T1 belongs to R, because everything is similar to itself. So this relation is true here for all T1 belongs to A. So R is reflexive relation. For reflexive relations, this type of relation should be there. 1 1 belongs to R, or AA belongs to R, or T1 belongs to R. Here this condition is fulfilling. That's why this relation is reflexive relation. Now T1 T2 belongs to R, where T1 T2 belongs to A. Also T1 is similar to T2, then T2 is also similar to T1. Implies that T1 belongs to R also. So R is symmetric relation. For symmetric relation, you observe that if AB belongs to R, so BA also belongs to R. So this condition is fulfilling here. So this is a symmetric relation also. Now T1 T2 belongs to R and T2 T3 belongs to R, where T1 T2 T3 belongs to A. Now it implies that T1 is similar to T2 and T2 is also similar to T3. From this relation, T2 is also similar to T3. Now T1 is similar to T2 and T2 is similar to T3. It means T1 and T2 is also similar. So we can write T1 is also similar to T3. So T1, T3 belongs to R. So R is transitive relation. Thus R is an equivalence relation because it fulfilling all the three relations: symmetric, reflexive and transitive. Now we know that two triangles are similar if their sides are proportional, and we see that sides of triangle T1 and sides of triangle T3 are in proportional. What are the side of triangle T1? It is 3, 4, 5. And what are the sides of triangle T3? It is 6, 8, 10. And when we are cancelling it out, 1 upon 2 is coming in every case, and that is constant. So thus we can say T1 is related to T3. So this is our required answer. Now question number 13 we have. It is a very good question and very important questions we are discussing today. Question number 13. So that relation R defined in the set A of all polygons as R is equal to P1, P2 such that P1 and P2 have same number of pages is an equivalence relation. So we have to prove it equivalence. It means it should be reflexive, symmetric and transitive. And what is the set of all element in A related to the right angle triangle T with sides 3, 4 and 5? We have to check it also. Now we are doing it solution. We have given R is equal to P1 comma P2 such that P1 and P2 have same number of sides. Now where P1 P2 belongs to A. Now every polygon has same number of sides to itself. Everything has same number of sides to itself. So we can write P1 comma P1 belongs to R for all P1 belongs to A. So R is reflexive relation. Now P1 P2 belongs to R where P1 P2 belongs to A. It implies that number of sides in P1 is equal to number of sides of P2. It also implies that number of sides of P2 is equal to number of sides in P1. Because if P1 and P2 have same number of sides, so we can write these two lines. It implies that P2 comma P1 also belongs to R. So R is symmetric relation because we proved that P1 comma P2 belongs to R and P2 comma P1 also belongs to R. So this is our required conditions. Now P1 P2 belongs to R and P2 P3 belongs to R, where P1 P2 P3 all belongs to A, set A. It implies that number of sides in P1 is equal to number of sides in P2 and number of sides in P2 is equal to number of sides in P3. Now P1 is related to P2 and P2 is related to P3. It means P1 and P3 is also related to each other. How? Number of sides in P1 is also equal to number of sides in P3. So we can say that P1 P3 belongs to R. So R is transitive relation. So this satisfying all the relations, reflexive, symmetric and transitive. So we can say R is an equivalence relation. Now we also ask in this question that which related to T. The set A is set of all the triangle which are related to T. So set of triangle is related to T in this case. So this is our required answer. Now we have question number 14. It is a very good question also. Let L be the set of all lines in xy plane and R be the relation L defined as R is equal to L1 comma L2 such that L1 is parallel to L2. So that R is an equivalence relation, find the set of all lines related to the line y is equal to 2x plus 4. So here we have R is equal to L1 comma L2 such that L1 is parallel to L2 where L1 comma L2 belongs to L. Every line is parallel to itself So we can write L1 comma L1 belongs to R for all L1 belongs to L. So R is reflexive relation. Now if L1 comma L2 belongs to R, where L1 L2 belongs to R, implies that L1 is parallel to L2 and L2 is also parallel to L1. So we can write L2 comma L1 belongs to R. So R is a symmetric relation. Now L1 comma L2 belongs to R and L2 comma L3 belongs to R, where L1 comma L2 comma L3 belongs to L, implies that L1 is parallel to L2 and L2 is parallel to L3. So it implies L1 is also parallel to L3. So we can write L1 comma L3 belongs to R. So R is transitive relation. So it satisfying all the conditions, flexive, symmetric and transitive. So this R is an equivalence relation. And the set of parallel lines related to line y is equal to 2x plus 4, because this is of the form y is equal to 2x plus c, where c is any arbitrary constant such that c is a real number. So hence this question is proved. Now question number 15, we are following NCERT book, so we can check question from NCERT book. It is an optional based question. Question is long, so I am reading this. Let R be the relation in the set 1, 2, 3, 4 given by R is equal to 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3, 3, 2. Choose the correct answer. So when we are observing this condition, so its option B is right, which is R is reflexive and transitive but not symmetric. You can do it yourself. It is your homework question. Now question number 16 we are doing. It is also an optional based question. What is the question? Let R be the relation in the set N given by R is equal to AB such that A is equal to B minus 2 and B greater than 6. Choose the correct answer. Here relation is A is equal to B minus 2 and B greater than 6. So option number C is satisfying this condition, because this A is less than B by 2 and belongs to R, and because it is always greater than 6. So this is our required answer. So today we complete exercise 1.1. Thank you very much.